A few people just joined. I want you to sell the vision of the cloud to me with just one benefit. Why should I use AWS cloud, or why should I use cloud computing as against just traditional data centers or things like that? I'm going to call names though. I don't want anyone to escape. If you're in the class, you're in the class. So I want to make sure that you're here. I'm going to ask Folashade, do you want to try? Benefits of the cloud. Why should someone use the cloud? Yeah, go ahead. Unmute yourself and you can speak.
For save storage, document storage and other things.
Yeah, for storage. Okay, that's good. To store your data safely. That's another one. Okay. Well, thank you. We're gonna go straight into it now. And we're gonna start with a prayer. Heavenly Father, we pray for this class. I pray for retention. I pray for understanding. I pray for the ability to teach these things simply and memorably. In Jesus' mighty name, amen. All right, so we have a good number of things to cover. I don't know how many of you have actually tried the tool I shared, which is the AI tool for getting some practice questions to confirm your knowledge, to make sure that at least you're making significant progress. So let's jump into today's material. Can we all see the screen?
Yes.
All right. All right. So we're gonna do a lot of recap just to see what we've learned so far. Remember, I talked about the well-architected framework, and I want us to go back to that again and just have a clear remembrance of what that is. So the well-architected framework is a guide to how to use the cloud efficiently. So there are many domains there. There's security, which focuses on the data's protection. There is cost optimization. You want to spend just what you need, right? Performance efficiency is when you buy those resources, you want them to do the job without breaking the no, you want them to do the job efficiently with the right amount of resources. So this has to do with right sizing, right? Operational excellence speaks to making sure that it is doing what the business requires. So you're using all these technologies together to meet business goals, business needs. Then we talked about reliability, which has to do with the ability to recover after failure or to handle failure. And then sustainability has to do with social and environmental impact, right? And so that was something I wanted us to be very good at. A lot of questions come in the exam with regards to that. And in your practice, if you eventually take cloud computing a step further, you want to be a DevOps engineer, or you want to be a solutions architect, or you want to just be a cloud practitioner, whatever path you take, this well-architected framework will always come up, because you always want to build for security. You want to build for cost optimization. People don't want to spend too much money. So you want to make sure that you're doing those things. And so we talked about cloud technologies and services. We started with AWS Management Console, which is where everything happens. All the services are found in the console. And we talked about the identity and access management, which is IAM, short for IAM, right? In identity and access management. And we mentioned that there is the AWS account, which you create. Every individual that wants to use AWS needs to have an AWS account. That is the first thing. You create an account. Now in that account, the account gives you access to the different services that AWS offers. To use any of those services, you need to have a particular identity or entity in that account. And the entities we have, or the identities we have, are users, roles, and then we have something called groups. User is the one who can perform certain specific actions as defined by the policy that is attached to the user, right? And then role is basically a temporary assignment that is given to you. So I can say, this is your task, and I don't want you to have that task in to infinity. I want you to have it only for the time that I want you to have it. I would assign a role to you as a user, right? And all these role, user, all of these things function based on a policy, and a policy is just a statement written in a format called JSON, just a simple script that I'll show what it looks like to you when we start going into some of the services. It gives instructions about what you can do, what you cannot do as a user or a role. All right, and so that's something you must be very, very clear about. And then Amazon resource name is what defines uniquely every resource in AWS. You don't really need to know more than that, just that. How can you access AWS? You can access via the console, through the CLI, or through SDK. CLI and SDK require what? Who can tell me what we need to use to log in to AWS resources using the CLI and the SDK? What are they called? Who's my good student in this class? Let's check.
Access keys.
Very good, very good. Access keys. And when we want to access the console, what do we need? What do we need? Password, yes. Username and password. Right? Very good. So remember that you cannot use access keys for console access, right? So very, very important. Then we talked about the root user. These are some of the things that the root user must have. Number one, they must have multi-factor authentication for a lot of protection. You don't want too much access. You don't want any entity to have unlimited access. That is really bad design. Make sure that the root user only has the necessary permissions. Sorry, don't use the root user for every activity. You don't want to use the root user for every activity. You want to create a role or a user with limited permissions to perform those actions, because the root user is the king of all the users. It can do anything and everything. So you want to restrict, first of all, who has access to the root user credentials. You also want to make sure those credentials are difficult to crack, so use a strong password. And then also use multi-factor authentication. And then don't create access keys, because you don't want anyone to be able to get those access keys and log in using the CLI with this root user. Don't do that for any reason. Now, there's a concept I wanted to bring to our minds on this thing here. When we talk about identity and access management, one of the best practices, and I want us to write this down because it's a tested idea in the exam and just regularly. So there is something called the principle, and I think I should type it. There's something called the principle of least privilege. Who can tell me what the principle of least privilege means? You can take a guess, but you will not be far from it.
Access control,
Very good.
where you don't have elevated privileges in an organization or an enterprise.
Exactly. That's exactly right. So the concept is Oluwole should only have the access that he needs. That's the principle of least privilege. Why do we want to design things this way? Well, it just makes sense. If I give him financial billing access and all his business is the networking aspect of things, that's bad, because now I will start to see, hey, so you have this much money, but you are paying me this amount, right? And anything can happen. So I'm just giving you an example of why you need to have least privilege. But there's also the worst case scenario, which is if you give someone access to do something, like delete delete resources or create users, that could be disastrous, because if you give me permission to create a user, I can add a policy to that user that is more powerful. So you want to make sure that you're only giving the amount of privileges that they need, not more, not less, just exactly what they need. And the least permissions they have, the better. So in my practice, you find out that we just give what is necessary, and then if they need more, they reach out, and then we look at it, we validate, yeah, it's fine, and then we give them the clearance for that next level. So this principle of least privilege applies to IAM. So the policy we put on a user must follow least privilege. What we put on a role must follow least privilege. This is very, very important. Do we understand that? So that's the principle of least privilege. So let's come back and review some of the things that we learned in cloud computing domain 3, which is the technology and services, cloud technologies and services. And so we looked here at compute, and what we want to know, what we're expected to know according to the exam guide. Number one is we need to recognize the appropriate use of different instance types. When should we use a compute optimized instance type? When should we use a storage optimized instance type? So this is basically what they want you to know. Of course, if something requires more storage, you use a storage optimized instance type. If it needs compute, that's very easy to remember, right? Then the next question here, or the next aspect, is we must recognize the appropriate use of different container options. And we're going to talk about containers when we get to discuss some of these services, other compute services. We're not there yet. All right. Then recognize this different serverless. We'll talk about serverless today. Recognize that auto scaling provides elasticity, which we talked about in our last class, that when you can auto scale, it means that you don't have to think too much about, you're not the one that has to manually create new instances to handle the traffic that is coming to you. You just need to set up a rule that allows that auto scaling to happen. And when those resources are no longer used, it scales back down based on utilization, right? And then we're going to learn about load balancers, the purpose of load balancers. Who can tell me what a load balancer is used for? We talked about it on Thursday. What's a load balancer used for? What is a load balancer used for? The answer is in the name. If you see the exact thing I just said and flip it over and just change the words, you already know what it is. Who's gonna try?
Well, it balances the load of a system.
Yeah, so help me sound more technical. Just a little bit more technical.
Okay.
You did good. Like, you're right, balancing load. But what does that mean? Is it like me?
Yeah, I know what it means, but like
the people that used to sell bread and they balance. Is
Traffic,
that
right?
No, okay. When there is traffic, it
yes?
helps to manage, essentially
The
prevent the system from
distribution.
crashing.
Yes, good. So it aids the distribution of traffic to multiple nodes. That's just the technical way of saying it. So if I have 5 EC2 instances, I don't want all the traffic to hit only one. That doesn't make any sense, right? I also want a system where if one of them fails, no traffic should be going to it anymore. And that's the job of a load balancer. All right, so that's good. Good try. Thank you. I don't like silence. If you just, if I ask a question, just try to speak so we can move forward. There's a lot to learn. So Elastic Compute Cloud is what we started with. This is one of the first and foremost services. I'm going to do a demo instead of just going through this again to explain how EC2 works. All right, and I think you're going to like that. So And this will be very shocking for some of you that, oh, it's so easy to do this. So what is EC2? EC2 is a virtual server in the cloud. That's pretty much what it is. What does that mean? When we say virtual server in the cloud, we mean we can literally have a server computer immediately. It is elastic, it can expand, we can do more with it. So I'm going to log into my AWS account. And for many of you who are saying, I can't wait to create my AWS account, you know, I would say you can feel free to create it, but don't do anything yet because it's going to be attached to your credit card. So don't do anything that I don't tell you to do. Anything I do here on the video, if you watch it again and you want to try it, will be free of charge. So you can do that. But for the sake of this class and for the sake of your credit cards and your account, you don't need to do that. So here I am. I'm using the dark mode. I don't know if it's better in the dark mode or light mode. Let's see. I think light mode is fine. All right, so let's go to EC2 and see what it looks like. Now, who needs an EC2 instance? Anyone who wants to have like a web server or wants to host their application or wants to build any kind of software application, you can use an EC2, because what is an EC2 at the core? It's just a server. It's a computer that you can put anything in. So we're going to do a quick run and I'll be very fast. I'm going to choose the region I'm going to choose here is North Virginia, because things work faster in North Virginia and I'm very close to North Virginia physically. So what is the first thing I'm going to do? I'm going to look for EC2 and I'm going to go there right away. So here's EC2. Please pay attention to this demo because it's going to explain some things that when we get to the networking aspect of things, I'm going to come back to this to explain some things that I might brush through today, because everything here, the knowledge builds on top of each other. So now here's my page. Let me put this on full screen so you can see better. So first thing we notice is first thing we notice is on the left side, there are a number of things here. We see instances, then we see images, elastic block store, network and security, load balancing, and auto scaling. So when you think EC2, these are all the things you need to know about EC2 at its core. Now, when we talk about instance, we're addressing things like what instance type are we using, right? Are we going with savings plan to save money, reserved instances, dedicated host, or are we just using spot instances where, it's like NEPA, whether it's there or it's available or it's not available, we don't care. We just want to get it very cheap. And then launch templates. If we wanted to have multiple EC2 instances launched at once, we can use a launch template. So it will just do the same thing over and over again, right? So that's what instances is really about. Like an instance is literally a computer in the cloud. Now, image, what is an image? Image is basically, okay, now you have a bare metal computer. What runs on that computer? What operating system runs on it? What runtime runs on it? All of that is determined by the images, right? That is very, very important, because if you understand this, everything else is a lot easier. So you can pick from the catalog that lists all the different AMIs that we have. For example, if I click here, I don't have any here, but I can actually create one or launch one from something called the AWS Marketplace, which we'll see. There's a catalog that lists all of them. For example, if I want to build a computer with Linux operating system, you can see it here. I can select that. There's Mac OS. If I want to create an Apple computer or an Apple server, I will just use the Mac OS, and I have different options for Mac OS. Now, if I'm also using Linux, but I want Red Hat, which has the Red Hat license, I can go with Red Hat. So you can see that there are many options here. Ubuntu, for those who want a graphic user interface for Linux. You have Ubuntu. Then guess what? The obvious one, Microsoft is there. Windows. You can Debian. There's also the one that is for deep learning. So there are different AMI. So what's an AMI? It's just an image that determines what that computer is going to be used for at its core. So it is server, but what does it do? So you can see that there's Windows Server core base. There's the one for database as well. If I want to host a database, or if I see with SQL Server. So for those of you who don't have any compute background, some of these things may sound new to you, but if you have a little bit of compute background, you would understand some of the things I'm showing you. So you can see how there's an almost an inexhaustible list. The quick start ones are 45. If I go to the marketplace and I say, hey, I want one for gaming, and I go to AWS Marketplace, I can choose from a wide range of more, stuff. Like, for example, if you're into networking, you would find this useful. Like Cisco has its own image, Cisco Catalyst for SD-WAN and routing. So if I select this particular one, this can be the AMI that will run in my computer. So it will be primed for networking services, right? Qualys. Some of you would know some of these things I'm showing you here. Let's see if there's any particular one. There's one I'm curious about. Pricing model, pricing unit, free trial. Let's say applications, right? Let's say applications. We can see that there are different applications here. If I choose IT business, you see they are the ones for business. So depending on what you want, you can even come to the marketplace and buy. But notice that there are cost implications for whichever one you pick here. Okay, so I just wanted to show you this. You have options. For example, if you're into schooling, schools have something called Moodle. It's an open source learning management system. So if you want to create like an education based instance, you can do that. So I'm just showing you that you have something called AWS Marketplace, where you get more options than where you would find in the normal one here. There's also something called community AMIs. So these are the ones that are published by anyone. So if any of you create an AMI and you just want to publish it for people to use, you can put them here. And so you see there are more specific things here. Let me even see if there's anything with regards to video. Nothing is on video there. Oh, video conferencing, video editing. So if I want to edit videos, literally it says this one is called OpenShot Video Editing Cloud API. It's a REST API framework which allows videos to be created, edited, transcoded, animated, and so much more. So I can literally use this, build it, and use it for what I want it to do. So you can see how this is basically a computer in the cloud. All right, so that's for AMIs and images. Elastic Block Store has to do with, you have a computer, what's the hard drive, where you put in the storage? So we use something called block storage, which is here is called Elastic Block Store. Why is it called elastic? Because it can expand and expand depending on the space that you need. And all you just have to do is you create a volume, you'll ask you which kind of volume do you want, and then you can choose the size. I want it to be 100 gigabytes size, or I can even go to like 1 terabyte, and all that. So I'm just showing you that you have all these options. And then network and security has to do with protection. Who can have access to my instance? Can people access it over the internet? Can people have a secure access through like something called SSH, which is a protocol? All of that is under security. And load balancing. If I have multiple instances, can I direct my load to different paths? So of course, this is I'm just showing you the dashboard of EC2. So let's create one, right? That would be a fun exercise. So we're going to create one, and I want us to all share our thoughts. Like, what do we want this computer to be and do? So as I ask questions, just answer in the chat so that we are able to go through it together. So now what do I do to start? I just come to launch instance. This is the first place to start. Now, if I have a server computer on my local system somewhere and I want to migrate it to the cloud, I will choose migrate a server, but I don't have that. So I'm going to just click on launch instance. And so now it's going to ask me a bunch of questions. The first thing is, what's the name of my web server? I'm going to call it, who's the lucky person? I'm going to call this thing. Let me see. I'm going to call this PC. All right, so it's Yemisi's PC. And notice the way I put the name, because the tags are, I think does it allow for spaces? Oh, it does. So Yemisi's PC. I don't know if it takes special characters, but let's see. So now the next thing I have to do after giving it a name is, okay, what AMI is going to run on it. So an AMI is a template that contains the software configuration, which is what the operating system, the application server, and applications that we need for the instance. So what do we want? Who wants to choose for me?
Ubuntu.
Ubuntu. All right. Okay. Let's choose Ubuntu. Most people will be familiar with Windows. Others will be familiar with, for the sake of this class, because Ubuntu will require a special kind of set of keys. So let me avoid that just for the sake of the example. So let's go with Windows. Yeah, confirm changes for sure. All right, so we'll go with Windows. Now, there are different kinds of Windows, right? Windows Server 2025, which is like the latest one. Or we can go all the way back if we are looking for compatibility, like Windows Server 2019. And you can see different use cases. This one says with SQL Server, so it's for database. We're going to go with a very simple base. So the latest one. Notice that on the side, it says free tier eligible, meaning I won't have to pay for it. So I'm going to go with that one. And then I'm going to now be asked a bunch of other questions. So it tells me the description, Windows Data Center Edition. They expect this computer not to be running in a person's house, but in a data center. So that's what differentiates it, right? So 64-bit, username is root, all of that. So we're good. The AMI ID is good and it's trusted. Now, the next question is, what is the instance type? So instance type, like I said, depending on the kind of work you want to do, you would choose. So there are different families. There's the T family, T3 family, which is the cheapest, right? It's cheap and it's just for like quick things. For example, notice T3 micro only has 1 gigabyte memory, meaning you're not doing anything serious. There's T3 micro, T3 medium, which is 4 gig memory. But then notice the only one that has free tier is T3 micro. So I'll go with that one because I think there's a free tier version of that one. And if I want all generations, I can choose that. But let's say it's just for testing, so I don't need too much memory. Just the VPC should be just 2 and that. Now the next thing they will ask me is key pair login. That means, how do I want to log into this instance? Well, I'm going to create a new key pair, which is the recommendation. And you don't need to know too much about this, but a key pair just basically allows you to connect your instance securely because it's in the cloud. You are in your computer. How do I connect to a computer in the cloud? I need access a key pair. So I'm going to call it EMC key pair, so I don't forget. And I'm going to go with this format because I will need it later on. So create key pair, and it's going to download. So it has downloaded. Network settings, I'm going to skip this because it's going to take too much time to explain. But every resource that you create in AWS is first of all created in a region, right? We already learned about regions, right? There are regions, there are availability zones, and edge locations. Now, everything is going to be in a particular region. Like right now, we're in North Virginia. But every EC2, please, this is something to write. This is noteworthy. Every EC2 is going to be in an availability zone. Who can tell me why that's the case? Why do we have an EC2 instance in an availability zone, not just hanging around in a region? maybe that's a solutions architect level question. So let me just explain why. One of the reasons why. Of course, the resources that you're going to use with that need to be in the same area. For example, it doesn't make sense if I create an EC2 instance in one availability zone within North Virginia, and then I create its hard drive in Asia. What's wrong with that? Who can tell me what is wrong with doing that?
Latency.
Latency, right? Like it's far. It's very, very far. So before I will even be able to copy files or send files, I will sleep on it, because normally our computers, our laptops, the memory is right inside it. So it's super fast. You don't even know that when you type K, when it shows on Microsoft Word, the speed at which that happens because of there's low latency. But when you now have the memory or the drive in a different location, it just doesn't make sense. So they require that the EC2 instance is in an availability zone, and the volume that you attach to it, volume meaning the storage, should also be in the same availability zone to make sure that it is the closest it can be to the device. All right. And remember, an availability zone is a group of one or more data centers that are connected with super ultra fast low latency connections. Okay, so network settings, they're going to give you a VPC. A VPC is called a virtual private cloud. It's literally your own unique room in your AWS account, a room where you can put different things inside. So they will give you by default a VPC, so you don't have to change that. There's something called a subnet. We'll learn more about subnets later on. And then we auto assign public IP. It's fine. We don't want to be the ones to determine what IP address the thing would have. Then we have things like firewall, which is protection for the EC2 instance. So to protect your EC2 instance, this is another exam question that we'll learn more about as we move on. To protect your EC2 instance, you need to use a security group. All right. So EC2s are protected by security groups. Meaning, if I want to access the EC2 instance, the security group is going to ask me a question. Who are you allowing to access? So in this case now, because we're trying to connect to a Windows computer, there is a particular protocol we must use. A protocol is a language that it understands. And so I'm going to go with RDP, Remote Desktop Protocol, which allows me, in a sense, to remote access the computer. How many of you have used tools like TeamViewer, or what's the other one? TeamViewer is the popular one, where someone can, even Zoom has that feature. Some of you have experienced it, where someone can literally take control of your computer and do stuff for you. Who knows what I'm talking about? That thing is called remote desktop. It uses a particular protocol to make that possible, and that protocol is RDP. All right. And so it allows traffic from, you determine where you want it from. So if I know the IP address that I want the access from, so if I only want, for example, Adefisola to access this instance, I will ask her for her IP address, then I will add it here. So she will be the only one that can log into that system. Who can tell me what principle we are following with that? I've shared it today. I've taught you today.
Least privilege.
Beautiful. The principle of least privilege. So what we're going to do for this test is bad practice. You don't want to just allow anywhere, but because we don't have any reason to not do that today, I'll leave it as anywhere. And then is asking me, should we allow HTTP traffic from the internet? And should we allow HTTP traffic? So HTTPS is secure, is SSL, which most websites have, right? When you want to go to a website, you will quickly see that HTTPS. It just means that it's secure. It has a certificate protecting that site. So I can accept all of these because I want all kind of traffic just for the sake of this example. And then the next question they will ask me after network is, what storage do I want? So I can decide. I want it to be, now free tier free tier, if I don't want to spend money, 30 gig is what I can. If I want to spend more, I'll raise it up and I can spend. So for the sake of this class and for it to be free of charge, I'll stick to 30 gigabytes. And then you ask me what kind of storage do I want. Now, general purpose storage is safe because it's general purpose. But if the kind of application that I'm running has a lot of input output, like there's a lot of transfer of data, right? Read and write, read and write, read and write, read and write. I will go for a provisioned IOPS because IO there is input output. That's the meaning of IO there. So basically, when you say provision, you are saying I want it to be specifically for this use case. So, but for the sake of this example, I'll stick to GP3 because it's just ideal. All right. There's the old one, magnetic. Nobody uses that again, but it's the cheapest, right? Think about this as hard drives. Like, I mean, so some of you know this from just being tech people or just people that have gone to like a store, maybe like Best Buy or something, and you want to buy a hard drive for your computer. A normal hard drive in those days used to be, SanDisk, all those, those devices. They were very big and thick, and they had this very, very weird cable that was, very, very fat, and you'd plug it to your computer and you can store stuff on it. And sometimes if you plug it in, you hear it vibrate like it's very hot. Sometimes it can get hot. So some of you don't even know what I'm talking about because maybe you are Gen Z. I don't know, but if you were born a lot further, you know what I'm talking about. And so that means that thing is called a hard disk drive, HDD. There is an actual disk inside that is spinning, right? And it is writing your data into that disk. But over time, they started to invent newer methods of storage, which we now have called solid state drive, which is SSD. Now, this one doesn't have a spinning disk. It has a different methodology of how it writes, and it's more secure, more stable. That's why nowadays you see a hard drive, 1 terabyte, 2 terabyte, and it's as small as it can be as small as something like this, like really small, right? Why is that the case? Because technology is getting better, and so that's what they offer you in the cloud too, solid state drive. But if you wanted the old one, this one is not compatible anymore, but there's the option. All right, so that's for storage. So with this, I've actually covered a lot of theory that will be tested in the exam in a way, and you'll see what I'm talking about very soon. So that now there's advanced details like, okay, what instance profile of that. I'm not going to touch all of these things because this is required for you if you know what you are doing, like if you know exactly what you're looking out for. Let me show you one thing that is important here. So as you're creating this now, if you want it to be a spot instance, you can choose here and say, I want it to be a spot instance, meaning give me the cheapest price you have. I don't care if this thing goes down or not. And for the sake of this, because I want to see if it actually disappears after we create it, I'm going to create a spot instance. So request spot instance at the spot price capped at the on-demand price. I can even come here and customize the options. The good thing about this is I can set my price. This is how much I want to pay. And if it's available, they give it to me. But I'm going to set it to no maximum price. And I'm just going to leave everything as default. And then I'm going to come to the summary. The summary here tells me I'm in the free tier. So in my first tier, I have 750 hours of this T2 micro or T3 micro. Instance usage in the free tier per month. I have 750 hours of that public IP address. So I'm not paying for anything for the first 750 hours, which is great. And how many instances am I creating? Just one. This tells me I can create 5, 10 of the exact same computer system. So I'm just going to go with this one. Everything looks good. I'm on a Windows computer and I have a security group and it's 30 gig space. So I'm going to launch and it's going to wait for it to process. So normally this would take a long time to do, but now it just says I've launched it. How many seconds did it take to build an entirely new computer? So now I'm going to go and look at the instance itself and each instance has a name. It has I dash and then a very, very random string of numbers. All right, so numbers and letters. So can you see what I have on my screen now? I have an instance running. Here it says PC. This is the instance ID in case I want to identify it. It's running. It's T3, but it's still initializing right now. There are some alarms. Which availability zone is it in? US East 1A. Remember I told you the region is US East 1. Availability zone will have an alphabet after it. So that's that. And then this is the IP address, 34.228.213.147. That's the IP address public that I'm going to have to be able to access it from. So literally, let me see if I copy this IP address, even though I'm not logged in, let me see if it's going to, oh, sorry, I wanted to copy it. Not the private, the public. Yeah, I'm going to copy this just for the sake of seeing if it will work. I'm just going to type that IP address here. By the way, you know you can either type www.something or you can actually just type the IP address directly. And if I do that, it starts to load, meaning that, okay, it's trying to connect, but it can't reach it. And that's because of some settings I've made or haven't made yet. So I'm going to come back here and see if we can connect to this computer that we just created. So this is it. I'm going to click on, it tells me the platform is Windows. There's more information there. I have a key pair. And so I'm going to go ahead and connect. So I'm going to click on connect because connect is how I will know if it is running and what it is running on and all that. So I'm going to go with RDP client because that was the method I created. And I'm going to connect using RDP client. The first thing they want me to do is download something. So I'm going to download it. This is the remote desktop file. This is the file that I put on my computer. And I will use the key pair that I just created to log into that computer. So I have the key pair here. Let me open that. It's not letting me open it here. Okay, hold on. I'm going to open this file and it's going to ask me a bunch of questions. Do I know this? Blah, blah, blah. Am I going to connect to this IP address? Yes. So I'm going to click on connect. So what you guys are seeing now is the process of basically setting up a computer here. So they're asking me for my credentials, my password. The credentials of my computer just to make sure that I'm the right person. Oh, actually, no. This is the password right here. So it says when prompted, connect to your instance. This is the username and password we're going to use. So administrator, it's already there. And then get password. I'm going to click on that. Oh, password is not available. Please wait at least 4 minutes after launching an instance before trying. Okay, so I'm gonna wait. It's not ready yet. So while we are waiting, we'll come back. We can come back and check this. Let's go back to our slides. All right. Any question on what I just showed you? That's just the process of creating an instance in the cloud. And you can see that we chose T3 micro. You can see it's right in the middle here. It's a general purpose. It's just right there in the middle. So it's not tilted to any of the specific types. We talked about on demand, right? This is anytime I need it. Savings plan, if I'm going to commit to a 1 to 3 year plan. Spot instance is if I don't mind if it fails at some point, I have my data stored somewhere, or I have redundancy, or I'm okay with faults happening because they won't tell me when they will take it back. Dedicated host, I'm paying for the entire block in the data center of AWS that I don't want anyone else to share that resource with me. And we talked about load balancing a little bit, right? We said there are 4 types, but 2 that you must know. Application, which works at the application layer, and network, which works at the transport layer. Now, for those of you who have never seen this before and are wondering what I mean by application and transport and all that, I'm going to show you an image right now that will help you understand this concept a lot better. All right, so the OSI model, thank you for typing that out. So let me pull this. For some of you, this may just be like, wow, oh, I learned this in school. I didn't know that it would be applicable. Now you're going to see it in practice. I'm trying to download a picture. All right, we can use this one. It's really bad. Open image in new tab. All right, let's use this to make my point clear. How many of you have heard about the OSI model? Let me see. Anyone? Okay, you have. Good. Who else? Okay. All right. So for those of you who haven't, you don't need to know this to pass the exam. But because I'm not just here to teach you about the exam, I'm teaching you about the concepts too that you must know. Especially if you're going to have an interview, they will not always ask you like, hey, what does CloudFront do? What does all these things? They will ask you like some of the basic technical knowledge you need to have so that the cloud knowledge can make sense to you. All right, so 7 layers of the OSI model. There are 7 layers. Now think about it. The OSI model basically is just talking about how information moves from a sender to a receiver and back again. That's just all it is. So for example, if I make a call to Temitope, a phone call, I'm expecting Temi to hear, right? Temitope is supposed to hear what I'm saying and then respond, and I should get it back. But how does that happen? Magic? No, there's actually a process. And so this shows you all the layers that it must go through before that message is transferred and brought back. So it starts from the lowest layer, which is physical. So in the olden days, people used a physical phone with a wire, and that wire was taken into like a distribution system where all those cables were, people had to like, I forgot what they call it in telecommunications. In those days, they will like patch you to a particular line. You say, oh, you want to call this thing, we'll patch you. So they'll literally be connecting cables before the cable that runs to your house to your own landline. Some of you even had landline, I still remember my first landline phone in my house, 774-7216. That was my phone number, right? Multi-link, some of you remember that. So in those days, you had a physical thing until the invention of GSM, and then now we have like mobile networks and all that. But how does it work? You speak, voice goes into a receiver on the phone. That receiver has a microphone. It's called a microphone. It is a physical layer. So at that point, we're talking about collecting information using the physical structures. So it could be fiber, could be coax, and in this case, sometimes it can be wireless. It starts at the wireless level. And all these things are physical layers that you need, the devices. Now, once it gets into those things transform the information that you've communicated, whether it is your voice pattern or all of those things. It transforms it into frames or smaller parts that can be understood as data and transferred on the network. So in data, the second stage is data link, where you see things like, frames. Those are what are there. We have tools, concepts like Ethernet, switches, bridges, all of those stuff. Those are the things that work at the higher level of the physical layer. Then the next thing is those frames become packets. Packets are just structures that have more information attached to them. So with every level, stuff is being added to that data to make it make sense and to be able to transfer it in a structured manner over the network. So that's why it's called network layer, and it deals with packets. And this is where you start talking about IP address, IPsec, all of that stuff. So IP address is at layer 3. Now, at transport layer is where the transfer actually happens. So between physical and network layer, transformation of that voice, from just actual speech to signals has happened. Those signals have been transformed into ones and zeros that can actually be sent in a meaningful way, in a meaningful order, which is what packets are, to the destination, right? And then transport is the end-to-end connection. So you hear things like TCP, UDP. TCP has a way of verifying that the information has gotten to the sender. UDP does not. It just sends it. Then we have session. Session now goes a layer ahead and says, okay, yes, you're passing this information, but to which particular endpoint, which port are we using? For example, RDP is a port, SSH is a port, HTTP or HTTPS, those things later on are in the application layer, but at this point we're dealing with the connection to the port. So APIs, like we talked about, sockets, all of that stuff. So please, if you are very lost, it's okay, it's very normal. I just want to make sure that you've seen this. Then there's a presentation layer, which has to do with, okay, how do we now put that information together and arrange them in a manner that can be interpreted? So that's presentation. So now all this data and everything, we need to bring it in a point that makes sense. So it could be like MP3, right? That's audio file, or FTP is a file transfer protocol, SSL if we're adding a certificate. All these things come at the presentation layer. But at the end, it has to get to an application that understands everything that you said. So from the physical layer of hello, it goes into the application on your phone, which is the call app. And that call app can handle all the information that you have given. And its job is supposed to decompose it after it has gotten from this app to the next app, which is the app phone call app on your phone, or WhatsApp. The OSI model will also happen there, but backwards. So it will now break everything down back to a format that can be used. So that is the OSI model. So how does this relate to load balancing? Well, there are two kinds of load balancers that you need to know. The application load balancer, which basically balances load at the high level application layer. And there we're talking HTTP, right? That's the high level application. So in the exam, if you see anything about HTTP traffic and they're asking you which load balancer should you use, please don't think too much. Just say application. All right. And then if they ask you which one is the fastest, well, application is going to be slower than physical, for sure. Physical is the fastest, like it's you are talking to the device. So that's there. But the one that is the correct answer is transport layer, which is layer 4, because this is where the networking actually happens and is the fastest stage. All right. So OSI model is a very, very useful concept to understand. And so what I'm going to do is just share it in the group so everyone has an image of that. All right. And so we're going to come back to our slide. So remember, application load balancer will manage traffic at the application layer, which is layer 7. And then the network load balancer works at the IP address level, which is layer 4, like we saw, right? And it's faster. It's great for network performance. Please don't forget these things, because this is how they test in the exam. All right. So that being said, let's actually come back to see if our server computer is ready, and then we'll take a short break. Where is that? Where's our computer? All right, we're here. So connect to the okay, let's see if we can get the password now. All right, so now, yes, the way to generate the password is I have to upload that private key, which in this case I just downloaded. EMC key pair. I'm going to press open, and you can see everything. This is what the key looks like. It's very confusing, and so I'm going to click on decrypt password. Based on that, it will create a password for me. I'm going to copy it, and then I'm going to come back to this my remote desktop thing that they asked me, and I'll paste it, and then I'm going to maybe remember me and press OK. So it's connecting. So ladies and gentlemen, what you are watching or what you're about to see now is me getting access to another computer in the cloud. So it's connecting me from my own computer, creating a remote session for me to access another computer in the cloud. It's going to be a Windows system, right? It's going to be a Windows system. Here it is. Can you see? It is literally, where is it? Yeah. It's literally a different computer in my computer. It's loading right now, so we can't see much. But it tells me the name of the PC, Yemi's PC, gives me the IP address and where everything is located. And if I scroll down, it's saying please wait. Let me do full screen since you've seen it now. So it's building it, it's getting everything started. So does this look familiar? So I'm literally on a computer with Zoom with you, but now I'm also connected to another computer that I just built in the cloud. And so it is setting up right now. And because the memory is really low, I went with T2 micro. It's very it's the lowest and it's cheap. I'm going to have to give some time. Notice that the name is administrator. That's the default name. And once it applies the settings and launches, it will show me a literal Windows desktop. So does anyone have any question while this is loading on what I've just described to you, what I've shown you? This is how EC2s work. So guess what I can do with this now? Once it's set up, I can host my website here. So if somebody types www.oluwale.com, and that's what I'm hosting here, they will be able to access it directly. Do you understand? And it will be hitting our auto scaling load balancing system, where if I have 1 million people, it will not crash it because it will just help me direct traffic. But it's taking so long. I don't understand why it's taking so long. Do you actually have that website?
Yes.
Oh, okay. Just I don't know if it's for security reasons. People are still going to watch this video later, so I don't know if I want to. Are you okay with me opening the website? Where is it
Yeah, sure.
hosted?
Is HTTP.
Oh, just HTTP. Okay.
Oh.
Yeah, not secure. Okay, so I'm going to drag it just so people can see what that is. So this is his own website. By the way, maybe one project we could do if we follow through with this and you like it, I'll just say everyone should create a website, host it on AWS, and just for you to say you have done a project. I can plan for that, but I plan to do that for the next training, not for this one, for the solutions architect, because you need to get your hands dirty to really learn that one. So this is his own. Okay, senior business development analyst. I love that, and so this is like his page, professional narrative. I think everyone needs to have something like this. It's beautiful, where you just put your resume and your information and people can reach out to you. So notice that he said it's HTTP. So if I come here, there's no HTTPS in front. It says not secure because there's no certificate. If it was HTTPS, that means you would have been paying for a certificate and you have protection for this particular website. So there we go. And it's on WordPress. It was built on WordPress. So here we are. This computer is really slow and I don't know why. It doesn't normally take this long. I think the reason for this is when I'm testing, normally I'll go with a bigger, because I'm not really paying much, so I'll go for a bigger resource. But I don't want people who are trying this to go and spend money they did not bargain for. So I'm going to just leave this on the side. We can always come back. It's running. It's not going to stop. If I come back to the home page, I can see it here. It says Yemi's PC is still running. So it's fine, and no alarms, nothing is, all the status check is good. So I can always just come back here and see how things are doing. Oh, it's setting up. It's still setting up. So I'll leave that so we can finish our resources. Let's take a short break. We've tried. Let's take a how does 5 minutes sound? Let's take a 5 minutes break and then we'll come back and learn more about the other compute services? Okay. We're back. We're back. So, as who's back? Let me be sure we're all back. Please confirm that you're back so that I can
I'm
proceed.
back.
All right, awesome. Who else?
I'm back.
Beautiful. All right. So, I want to say that the assignment I'm going to give us today, we have a lot of time to do it because the next time our meeting is Thursday. I want you to have learned as many services as you can. I made a video where I talked about AWS services and I didn't go into depth because those are the ones that they'll just ask you random questions. Please watch it, take notes. I put a lot of clues there. Take notes is very important because this exam, like I said, the first time I took it, that was long 2020 I think, or 2019. And then it was pretty hard because it was a new domain to me. Now I took it this few months ago just to like refresh and see, and it was it was shocking how much content had to do with what does this service do? What does this service do? This service does what? Anything that does this is what service. Like the questions were always around that, and you just have to know the services and the keywords. They're literally about knowing the keywords that describe a service. So for example, right now they won't ask this, but because you've seen EC2 in action, if they say a customer would like to have a virtual server in the cloud, which service can they use? Obviously you should go for EC2, right? Or a customer wants to store objects in the cloud, which option should they go for? S3. So those are kind of questions you would see, especially in database, all of that. So I've done a video that addresses most of the services. I have a second video coming out to strengthen your knowledge on some of those things, but coming to the class here addresses the deeper aspect. So I'm going to focus on the ones that they have more questions beyond just the what does it do. Like EC2, you don't see what does it do, you see questions on load balancing, questions on auto scaling, questions on network and security. So I want to make sure that I'm covering those things while you're also learning the ropes and you're able to do it as well. So here we are. This is the PC. It has launched fully. Notice that it looks very, very old school, and that's intentional. In the memory is low, so it tells you about the system. This is an EC2 Amazon based. Instance ID is there. This is the private IP address in case you have like a network that is not public, and then there's the public IP if someone wants to access it from the website. For example, if I go to EC2 let me see if I can actually copy this. No, let's see. Yes, I can click on it here and see if it would work. So if I click open address, let's see. If I had an application linked to it, it would open up, but I haven't linked any application to it. But I can back that location. I can put an application on it, like a website, like maybe Wally's website. I can put it on this, host it here, host it in something called Route 53, which is an AWS service for hosting your websites. You can use it to host domain names, and then I'll use this as the IP address behind it, the DNS address behind that IP, so that people can access it. But not right now because I have not set it up, it won't work. But yeah, and you can see that I'm here in this computer. The things I can do on my regular computer, I can do in here as well. If I click on start menu, right, it should show me the start menu. Super slow. Wow. One of these I can also check because I allowed public access to the internet, so I can literally click on the browser, and let me see if I can actually go online from that PC. I think I should be able to. What this tells me is that I should never go for T3 micro. This is if you desperately do not need memory you just want to run some simple code or something, that's when you go for this. Because see, it's very poor. Like, but notice that the network is fast, up to 5 gigabits. So it's not too bad.
Just wanted to ask,
Yeah.
does this work with your own compute, like the physical system? Does the memory, maybe, is it from EC2 or your system?
I don't think it's from my system because I'm doing everything fast on my system. Remember, this is remote access. So literally, all I have is a screen and a keyboard that they've given to me. Like the thing is there, but they've only given me access to remote into it. Remote means I can use my mouse, I can type my keyboard, and it will respond. The delay it rarely comes from my computer. It comes from the memory and all of that. Because if I want to even check, I can check the memory of this computer now. If I do Control Alt Delete, I think there's a way to do that on this control. Let me see. Ew, let me see. I don't know if I can do it here. I can run it and check, but so okay, I'm in here. You can see how it's really slow. I don't think it's my computer. I think it's from there. It's just very strange. See how it's not matching my own cursor. So just to show you the beauty of this, if I come here, and this is the beauty of elastic compute. Let me even this is a good example. I love this. So now my instance type is what? T3 micro. Can I do anything about that? I can. If I don't like it, I can stop the instance. And it says, after the instance, you will no longer be charged, blah, 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 blah. Anyway, that's fine. Stop. I'm going to stop it for a while. And it said I can't stop it. Why? Because it's a spot instance. So a spot instance means like it's based on availability. So I won't be able to do that. But what I can do is I can let me see. I can change okay, let me see. It doesn't allow me to do that here. Yeah, it doesn't, because it can't stop. Yeah, so let's let me see if I can actually change it from. I don't think I can change it from spot anymore since I've already locked it in. So yeah, I don't think I can. Let's just
So for sports, that means it drops the traffic or usability, or how?
So no, it doesn't drop performance. It just means that if anybody bids for that compute space, they will give that person. So I'm basically telling them I don't mind them taking it from me anytime because I don't really need it. And the reason for that is I don't want to be charged so much. I just need it for a specific amount of time. And when I'm done with it, you can do whatever you want. So that's the benefit of that.
So on demand, if you don't get it at the time you need it, what happens?
No, on demand, you will always have it. So to get a spot instance, it is already, there's a group of instances called spot instances. Like they are for audits, they are for audition. Like is the extra resources that AWS has that are not used. And so they don't want it to be wasted. So they might as well sell it for very cheap. But they are saying that if we need to take it from you, we can. Does that make sense? That's the agreement that you have with the spot instance. For this example, I shouldn't have done spot instance, but I just wanted to show you how that works. So now you see it's responding faster. My mouse is responding faster. That's without your data. Let me try and say, I don't want to sign into anything. Or from and start browsing. Okay. If I type google.com, and I press enter, because I'm connected to here you can just see it says network 2 internet access. Because I made it public, I can access the internet, and anyone who has access to this can access it as well. So that just shows me I can do a lot of stuff, right? This is what is trending. I can do that in another remember, this is still another computer than my own computer, right? And if I come to the settings, because it's a server computer, I have some access to change things. Like launch settings is here, server manager. This is where if you want to build a whole server system, you go to server manager. They'll ask you a bunch of questions. Do you want to use this as a web server? Do you want to use this as a for what they call those things, administrative access? So yeah, there we are, right? So this is, if you've worked with servers before, this is the page you'll be familiar with, and all that. So you create server groups, local server, all of that stuff. So again, this is built to work as a server. If I'm going to use it as a web server, I would configure it for web as a web server and run with that. So that is pretty much how this works. All right. Any other question? All right. So you remember that scaling there. I think that child wants to be in this meeting by all means. I'm guessing is a child. All right. So auto scaling. I already talked about that. You can scale up or scale out. Scale up means give it more, like I can move from T3 micro, which is super slow, to like M something. I can change the instance type. If I have more time, maybe in next class, I would do more examples to show that. Compute optimizer, basically, this is an AWS service that helps you right size. So you may not know what you need for the kind of workload you are dealing with. And so there's a tool called Compute Optimizer that will guide you on what to use, how to right size, to give you recommendations and all of that. So this is a service that works with EC2 to guide you and to give you ideas on what you should rightly use. So you first start with one, and then you open Compute Optimizer, then it will ask you a few questions, then to tell you, oh, use this one. For people who don't know what to use. That's what that is for. So we're entering another domain now, which is called serverless. All right. So be ready to learn a few new concepts. When we say serverless, what do we mean by serverless? We don't mean there is no server involved. What we mean is that we don't care about the server settings. Like that is blocked from our view. So there are services in AWS that say, oh, okay, well, EC2 is a server-based service. So you are dealing with the server yourself. Notice we had to configure a lot of things, instance type, all of those memory stuff. We had to do all of those things. So I'm going to explain it to you. Don't worry, Wale. So in EC2, we're dealing with the actual server, right? We're dealing with the fact that this is a server. You must configure it for as a web server. You must put all these settings. You're the one that is doing all the configuration, like you saw me do. In serverless, you're not doing all the configuration. All you are doing is you are bringing your application or your code, and AWS will do the rest for you. So while in EC2, for example, let's say we are here and this is our, I want to open that computer again. Connection lost. So you see, that's what what can happen to spot instances. You can lose it at any time. You have to, let me see. Yes. I've been signed out. That's weird. Why have I been signed out? Okay. That's strange. Sorry about that. But in EC2, right? Remember, it's a server thing. So you're configuring everything. In the instance, you're configuring it. You're configuring the AMI. You're configuring the storage. You're configuring network and security. You're configuring all this stuff. But when we say serverless, we are saying we are not configuring the server's part. We're only just worried about the application that runs on it. So that's a big, beautiful gift that AWS gives to you. Like, don't worry about the back end. We'll do the back end. We'll do all the memory. We'll do all of that. What's your code? Give us your code. And if you give us the code, it will run seamlessly with no issues. And so what services are serverless in AWS? Well, there are two core ones. There are many more, but there are two that have to do with compute or serverless compute. The first one is Lambda, and the second one is Fargate. So I'm going to talk about these two and show you what they look like. So Lambda and Fargate. What is Lambda? Lambda is basically a service that allows you to run your code, or it works as something called function as a service. Remember, we talked about infrastructure as a service, platform as a service, software as a service. Everything is just as a service based on what the service is. In this case, the service is bring your function and we'll help you run it. You don't have to provision servers. We will give you which language do you want, Java, Python, don't worry about it. We will give you the language you need. Just write your code. It can be as simple as a print hello. It can be that can be your simple code. And you see, so you notice that in AWS, for this exam, you don't need to be a programmer, but it helps to at least understand some of these concepts, right? Any application that you run is built on code, right? It's a code. Someone did programming, wrote everything that led to whatever software that you currently have or are using. And so Lambda helps you abstract all the hard work of building the infrastructure and configuring all of that. All you have to do is just bring the code, run it, and you get the results of what you are running. So you're not limited by what your code does. You're only limited by the fact that if the code is going to run for more than 15 minutes, don't use Lambda. Go for EC2 because you can use it on demand for as long as you want, right? But here, the maximum time for the code to run is 15 minutes. But your code must be super complex for it to run more than 15 minutes. So people use Lambda a lot. In fact, Lambda is one of the most powerful AWS services in recent history because a lot of people just make their life so easy. They use Lambda to send messages to other services to perform certain tasks because it's very easy and it's cheap. When I say cheap, you have free tier of up to 1 million free requests. So you can literally use Lambda for 1 million requests in a month and you won't pay a dime. So there are big businesses that are making so much money building their entire architecture around Lambda, and they're saving like crazy. So you can use Lambda to execute code in response to events. If something happens, you can use it to trigger your Lambda. Lambda will perform that action, run a code based on the trigger. So for example, I can have a system. This is a beautiful picture, right? Let's say I want to build a website, and the website is such that I want people to upload their resume. And when they upload their resume, listen to this. So when they upload their resume, I want to get an email sent to me that says you have received a resume. And I want it to give me that. I also want it to scan the resume for me and look out for some keywords. I can build that entire system with AWS. How would I do it? Number one, I'll create a website, create a space for you to upload. Now, that upload will go into my S3 bucket. All right, S3 is where I save files. Now, once it enters the S3, I have a rule that I've set in that S3 bucket that if a file comes in here, trigger a Lambda function that I've already written. So once it uploads, it will send a message to Lambda. Lambda will say, okay, run a command to that file to scan it. So the code, I would have written the code to do that. So the code will now scan the resume. Is the keyword there? Yes. If the keyword is here, please send an email to my email address. So at the end of the day, guess what? I will only get notifications from people who actually, not all the people that submitted resumes, there can be 2 million of them, but just the ones that have the keywords that I've asked for. So you can see how this is a very useful system. But notice that I used S3 for storage, Lambda to run a code because I don't need it running all day. I just want it to function when an action takes place.
Excuse me.
Yeah, go ahead.
Also, you said lambda. Consider again, please. About the lambda.
Yes. So Lambda performs actions based on an event that has taken place. You can set up Lambda to run a code based on another event.
Okay. Also, you mean like a resume and stuff?
Yeah, resume is one of the use cases. I just gave an example of how it can be used. It can be used for anything. Like I can use Lambda for pizza delivery.
Okay.
I can use Lambda for anything that needs like a response to an action. If somebody does something, then do this.
Okay.
Lambda is my best option for that.
So basically, it's like AI, right? It's like AI and stuff.
Not direct, not exactly, because it's code, right? You must have programmed something into the Lambda function. Like you have to write a code to do
Okay.
it. So it's not really AI.
Okay.
But it can work with AI services if you want.
All right, got it.
You
All
know.
right, thank you.
You're welcome. So that's the beautiful thing about Lambda. You basically can do compute work without provisioning or managing a server. So for those of you who are just thinking, I want to pass this exam, what do I need to know about Lambda? Number one, Lambda is serverless, which means you don't have to worry about the backend provisioning of server. It will do that for you. Number two, if you are trying to run anything that is more than 15 minutes, don't use Lambda. Lambda is not for long-term events, it's for short events. And use Lambda when you want to create a workflow. You want to chain multiple things together in AWS. You want to connect them based on an action. You use Lambda. All right, and it accepts multiple languages. That's another thing to know. For the sake of brevity, let me just show you what the Lambda looks like on the console. I won't run any code right now. Maybe I can just do a demo code for you. So here's the code, right? Let's just use this one. Very simple code. I'll copy it for the sake of what we're doing. So how does it work? You only pay for the compute time that you consume. That's Lambda. You run code without thinking about servers. So if I say create a function, let me go to Python and use Python. I'm going to copy a code. It's just supposed to run a code that says hello from Lambda. That's the code. So if I create a function, that's the first step. It's going to ask me, what kind of function do I want? Well, if I author it from scratch, I need to be a programmer. Or I can use a blueprint, or I can select a container. For the sake of this class, I'll just stick to it and say, okay, Temitope is the function name. Runtime, I'll choose Python. Architecture, I'll leave that, and then I'll go to create function. So now it will take me to a new page, and this new page is where I have to write my code, and I can make the code run based on a certain action. So if you notice, this is how it looks. This is the Lambda function. Here they expect me to type my code. So if I'm not a programmer, this will not make sense to me, but I'm just going to include the code I had, which is, hello from Lambda. And then I'm going to keep everything the way it is, Python. Now, you can see how this is the code. There's a trigger and there's a destination. This is what makes this thing very beautiful, because I can say, okay, for this code that I've done, can I use a command line for it? Yes, you can use command line to trigger this for sure. But you remember, it is an action. An action comes in here. You must add the trigger. The trigger can be from any source. It can be, if a file enters S3. It could be if somebody, if Alexa, if you work with Alexa, you can see if Alexa says, if Alexa receives a particular message, then trigger this Lambda function to run. CloudFront too. It could be if somebody accesses this website. So there are many. The popular one is S3. If I say S3, they'll ask me which bucket. I can choose a bucket. In this case, I remember I worked with Tojumi's bucket the other day. And I select that bucket. Which event? Okay, if somebody creates an object in my bucket, please do this. So I'm basically saying if somebody creates a file or object create events, and acknowledge that using the same bucket for okay, that's fine. And then if I click on add, notice I've created a trigger. So if I upload anything to that Tojumi25 bucket, then it will trigger this Temitope lambda function, which is, if I look at the code, it says, did I save it? I don't think I saved it. Oh, this is it, right? And this is what I want it to do. And then if I go to destination, after it runs this, where's the destination I want it to send the answer to? I can create a topic, SNS topic, to send to like my email, but I don't have time for that, so I'm not going to create a destination. I'm just going to go with this and say, okay, here we are. And then I'm going to go ahead and test it. So I'm going to test this code. Oh, actually, let's just go here. This is the code. So deploy. So deployed. So let's test it. Let's see if it actually works. So if I go to S3 now, let me open S3 in a new tab. And I say, where's Tojumi bucket? This is Tojumi bucket. I'm going to click on that. I'm going to say upload. So remember, any object creates action. So I can come in here and add a file, and the file can be maybe this CMS's PC for just to put it there. And then I'm going to press upload. Now, the moment I say upload, it's successful. So I'm expecting that it will trigger this lambda function to say hello from lambda. How do I check it? I didn't put a destination, but this is how I can check. I can come to monitor, and in monitor, if I give it some time, it would give me a list of things that have happened. Let me go to CloudWatch logs. By the way, we'll learn about this later on, but CloudWatch, what is CloudWatch? CloudWatch is a service that checks performance of services. Okay? So CloudWatch checks the performance of services. It checks if a service is actually running fine. So look at this. It shows me one of the log streams, and the log stream, if I click on it, you see it. It says start. It started. This is the record. If I open it, I can see the record. Or it tells me that yes, somebody uploaded a file, object create put. Which file was uploaded? Which bucket? Tojumi is here. What's the name of the file? Yemisi PC. And so because of this, it's triggered the lambda function. Do you see that? And it tells me how long the lambda function ran for. It ran for 1 millisecond. And it was built for 2 milliseconds, and yeah, so like this is it. This, all you see here is just a proof that something has happened, and this is a log report. So I just wanted to show you how that works. Now it may seem complicated. You don't need to know all of this now. The whole idea is just to show you that lambda is a short-term code running serverless option. All right, so let me sign out. Why? So I hope we get the difference. EC2 can do the same thing. I can go to my EC2 and guess what? I can run the same code and launch it. I can even install Python and run it. But why build an EC2 instance if all I want to do is run code? Do you get the difference? So that's the difference between serverless. Serverless is like, I'm not going to configure the infrastructure or set that up. I just want to do what I want to do. Another service that uses this is Fargate. Fargate is a serverless compute for containers. Now, containers is another beast that even me myself, I'm not the best at. I'm just really learning containers. The thing about technology is you keep learning new things. But containers are basically like a place where you can put your software and your packages together in an arranged format. So the major service that works with containers is Elastic Container Service. Now, this one is not serverless, right? It's not serverless. So the option for containers when you want serverless, the serverless option is Fargate. So we're going to go to Fargate and just look at it. We don't need to know much about how it works. But at this point, you're probably realizing, there's just so much, right? There's just so much. So, where's Fargate? Okay, Fargate is here, and it works with either Kubernetes or, and you'll learn more about this later, Kubernetes or the normal ECS service. So that's why I brought us to ECS, because even here too, you can create Fargate. So infrastructure to use is for the cluster can be Fargate, which is serverless, or EC2 instance. So you can see that for all of these things, EC2 is like the boss. You can use EC2 for anything, but if you don't want to do all of the configuring, managing, patching, all of that stuff that takes a lot of time, use the serverless option. If you want to run a short-term code, use Lambda. If you want to do a longer process that is beyond 15 minutes and you want to run a fuller program, use EC2, or as we're learning now, you can also use Fargate. Why? Because it's best for, if they ask you in the exam, which service gives you serverless compute for containers, immediately your mind should go to Fargate. Or if they say a customer wants to run their code for more than 15 minutes, now that can be anything. It cannot be Lambda because 15 minutes is the max for Lambda, but there is EC2. But if they say for containers, then your answer is Fargate. So these are some of the things you just have to learn. So for Fargate, you manage containers without, but these not containers on the ship. I hope you know that it looks like it from a technical standpoint, because in a container you have multiple things of the same type. That's the idea in the tech world as well. But it's for managing containers without provisioning or managing a server. So containers are packages of software that contain all the necessary elements to run an application in any environment. So you literally just carry a container to any environment and you can run it there. It will not need, all the dependencies are inside that thing. That's what makes it a container. And so it is useful for things that are longer than 15 minutes. In Fargate, there is no free tier. Lambda is very free for the first 1 million requests. So this is all you need to know about Fargate. We also have some other services that they are just worthy mentions. So I'm going to do that just to wrap up our training today. And then we'll look into S3 next, because S3 is another beast. But there are a lot of questions that come up on that, so you have to know it. All right, so other compute services. We've learned EC2, which is virtual server in the cloud. We've learned about Lambda, which is serverless compute for running code less than 15 minutes. We've learned Fargate, which is for containers. You're running code for more than 15 minutes, you can use that, and it's serverless as well. But there are many other services that we have that are managed by AWS, and you just need to know what they do. So there is what we call outposts. All right, so please pay attention to this. It's in the video, but just please pay attention to this. Outpost is literally the option you have where you can bring to your own premises, like you can bring to your own office AWS services. You're literally not migrating. You are not changing your infrastructure. All you are saying is, you know what, we have a very big business. We love AWS, we want to use the API calls, we want to use the console. Can you bring a segment of AWS into our office? That's called Outpost. So you can run AWS Cloud on premises. So they will literally give you a server rack. They'll give you storage for S3. They'll give you some of those things and bring it to your own premises so that you can interact with it as though you are using AWS. It's useful for people who want AWS resources, AWS language, AWS style of doing things, but you want it to be on your premises. That's when you use Outposts. All right. Then there's Light Sail. Light Sail is for people who just want to start a website. They don't know what to do. They just want a quick launch. You don't want to think too much about anything. You're a beginner, you're a developer that doesn't know anything, but you want to start a small project or a small website. You use Light Sail. All right. Batch is you have a big amount of workloads and you want to break them into smaller bits to perform tasks on them. That is what AWS Batch is used for. All right, it's under compute service. So any question that you see on like breaking down big workloads into smaller workloads, the answer is AWS Batch. Then Wavelength is for low latency for mobile users. So anytime you see anything about Wavelength, it just has to do with mobile devices using 5G and being able to connect easily. That's a service that AWS offers as well. So these are the other compute services that you need to know: Outposts, Light Sail, Batch, Wavelength. All right. I don't want us to jump into storage immediately. Let me give you something visual to help you solidify this concept. So let's look at Outposts. We can't really do much because, of course, I don't want to order any infrastructure to my house if I don't have like a couple of hundreds of thousands of dollars, right? So let's actually see what that looks like. So if I type Outposts, I hope you realize that all I've done is on the console, right? It's easy to handle. So I'm going to click on AWS Outposts. And if you want to learn anything about any service, this is the easiest way to do it. Create an AWS account and you don't even need to create anything. You just come there and read stuff. So you don't even need to create an account to read this. Just type it on the browser and you see it. AWS Outposts. It says AWS Outposts brings native AWS services, infrastructure, and operating models to virtually any data center, location, space, or on-premises facility. So to start running AWS on premises, all you have to do is place an order. There's a catalog you can choose from. What do you want, servers or racks, right? And then you have to understand a lot of these things to know what you need. This, as you can see that they are saying EC2 capacity, meaning they will bring EC2 to you, right? And you will need to have a particular support plan to be able to place an order. It's not anybody in AWS that can order it. So that's something to know. That's for Outpost. Light Sail. I like Light Sail because it's so cool. In fact, anybody here that wants to build a website or their blog, maybe you're here, you're just like, I want to write a blog or I want to do stuff, and you don't even know the technical jargon. This is where you will come to. So you get started with your first Light Sail instance. So how does it work? We can come in here, create an instance, right? That's the first thing they're going to ask you, to create an instance, and then they'll give you a lot of options. So which location are you in? US, okay. Which platform do you want to work with? If you want to work with Linux, choose Linux. If you want to work with Windows, you can choose Windows. It's almost similar to, what is that thing we just did? EC2, right? Very similar process to building an instance. But I'm going to go with Linux because it has more options. There's WordPress for my website. Yeah, so if you want Mac OS, you have to use EC2. You can't use Mac here because the blueprint is not here. All right. So but if you go to Linux, you have WordPress, you have LAMP. If you're a programmer and you want all these things, you can choose. I'm going to just go with like WordPress, right? And then you'll ask me other questions. Do you have Skipper? So of course, I'm also going to need a website. So those are things that all of these things will help me configure. Okay, so what network am I using? Dual stack. How much am I going to pay per month? Because of course you're launching your own site. So how much are you going to pay per month? The first 90 days will be free, but this is how much you start paying after, based on the resources you want. So if I click on $7, and I click on WordPress, I can leave the name like this and go ahead and create instance. it's going to, create it for me. So once I create it, of course, I can log in there and then go ahead and use the WordPress that is on it. You get, so that's like, it's so easy, but it's still creating, and I would like to come back and see how this works. Of course, while this is creating, see other things that you can do with Lightsail. You can build containers very easy. Databases too. You don't need to know much. Just come here and create a database. Networking, same thing. Storage, you can create a bucket directly from here. I can come here and say, what bucket do I want? Change my storage plan. Let's say I just want this 5 gigabytes is $1 I need to pay. I can do that. I can give my bucket name a particular name. Maybe in this case, I'll call it Ehizele, right? And you can see it's saying ehizele.s3.us, the whole domain. And then it's saying it's free for the first 12 months. And then I start paying $1 per month. So it's very cheap, like very, very cheap. If I go ahead and create the bucket, it will make sure that there's no other person in the world that has Ehizele. And you see, now I have it. So the question is, okay, now you have a bucket where you can store your files. How do I use my bucket with WordPress? So literally, if you don't know anything, you can come here and learn how to do it. A bucket can be where you store your blog posts, right? So that anytime you need it, it will just pull it out from there, or pictures or videos or anything. Now, if I want to deliver content, what can I use to deliver? Who can answer this question? What AWS service do I need to use to deliver content to people in their different locations faster? I want to deliver content to people. What service do I use for that? And I want to be able to cache that content close to where they are. What's the service that does that? Please don't tell me you've forgotten. Good. CloudFront, good. So you can see they're asking me, do I want to create a distribution? I can say, yeah, for this Ehizele bucket, because I don't know who is reaching out to me. Maybe Adefisola is in Canada and I'm here in the US. I need something close to her. So I'm going to go ahead and click on create a distribution. And again, it says 50 gigs per month is free. And all of this is going to be done with CloudFront. They're not saying it here because they don't want me, I don't know anything, right? So they're trying to make it very easy and simple for me. So they're saying, oh, it is a distributed network that is globally distributed for caching servers, right? So I already know it is CloudFront. And then, what is the origin of the CloudFront is my bucket. That's where I want to store movies for them to watch. And then I have different options. First year is free, so I'm going to go with this 50 gig per month. Ehizele distribution, maybe I just call Ehizele distribution, right? And then create. So the interesting thing is, as I'm creating it inside Lightsail, it gives me, see, domain, it gives me this .cloudfront.net. It's still creating it. And it's asking questions. There's cache, do I know how this works? If I don't know anything, I can start here. It's like, this is the easy way to start off with building applications if you don't know much. Now, how do I know it is actually working? If I come to S3, let's see if I have a bucket called Ehizele here. I don't see it here, but is it on my account? Yes, because it's inside Lightsail. So Lightsail helps to host it. All right. And if I were to, for example, let me go back to storage. You can see if I click on this bucket, all objects are private. Domain is here. Where is it? It's actually supposed to be. I'm supposed to actually see it. So objects. Okay, I can upload here. So I can upload a new object or a new file inside here. Let's say I'm uploading this folder or this picture. It uploads directly. Now I can give permissions, bucket policy, and all that. Is versioning enabled. I'll teach you all these things in our next class. But I'm just showing you that you have a lot of things. Domains and DNS. I can register a domain now. Let's say I want the domain to be www.ehizele.com. I'll check. Does this exist? Is not supported. So that is not available. But see the other options that are available and see how much they cost. So I'm just showing you can do this on AWS. You can literally create your own website. Also, I shouldn't have said www dot. I should have just put the domain. That's the challenge. Let me change it. Let me just see. Let me try this. Yeah, this domain is available. It is. I'm not going to create it, don't worry. But I'm just showing you that. You know, and then for $14 a year, I will have that website and I can put anything I want on it. But so now what would happen is I have to just know how to connect everything. I'm hosting everything on AWS right now, right? AWS has a domain server that handles all these names. So literally, you know what? For the sake of this, let me just create. I think I have one. I don't know if nsolutionary.com. I can check if it's available. It is. Wow, I thought I had it. So if I go here for $14, do I want to spend that money right now? Automatic renewal, no. Please don't lock me into it. So I can put my contacts, you know, and basically I can register it. Privacy protection, DNS zone, where do I want it to be launched? And I can go ahead and register the domain. They expect me to put some information because they want to know who I am, right? But this is something I can do here. And then guess what? I have instances where I can host the application itself. I have storage where I can store the content. I have networking that can help me distribute it to everywhere. I have the domain that hosts the website. So everything, you literally can build an entire thing. And for you, if you don't know anything about it and you're like, I want to create something for myself, guess what you can do? This one is still pending. Still pending. One thing you can just do is go to documentation, right? And you will see a lot of beautiful examples that you can follow. So getting started, you know, it's the easiest way to get started in AWS to build websites or web applications. It will do everything for you. These are all the features that are there. Who is Lightsail for? It's for everyone. If you're an individual developer or hobbyist working on a small project, you can use it. As your project grows, you can go ahead and add storage and you can even migrate it if you want. So that's just it. And so if you want to see like some good examples that people have done, so get started with Lightsail for research virtual computers, deploy PHP applications. So there are some sample things you can do. If you do a good research online, you'll find it. What is the other service I wanted to show you? Please, anything that if you create an account and you do something for testing, please delete it when you're done, or else you get charged for it. Okay, so don't forget that. Batch is, you know, like I said, fully managed batch service for running multiple things. So you create a job queue, you break down the job into different parts, and then you can run it. That's really what it is. The jobs can be defined by anything, right? They'll ask you a number of questions. What are the jobs dependent on? You can match it to anything. You don't really need to know more than the fact that you create a job and then you break it down into bits. That's all batch is about. All right. So, and wavelength, as we round off here, it doesn't even, you see, it doesn't even give you like so much, but it just works to, it's an EC2 feature that allows mobile phone connectivity closer to individuals. So these are the wavelength locations. There are wavelength zones that are closer to your phone, especially if you're trying to build applications that are based on your phone. We have availability zones, edge locations, but we also have something called wavelength zones that bring actual towers, like network towers, closer to you, and they tell you where they are, and you can build things around it. So that's all you need to know with regards to wavelength and all the above. We are out of time. I really wanted to teach you S3 today, storage, but I would rather just dedicate that to the next class that we're having so that you get to see it, and it's very fun. You store stuff, you download, create policies, set up lifecycle rules, and all of those fun stuff. We're going to learn all of that next week. So any questions? Any questions on what we've done today? If you want to create an AWS account on your own, what you can do is read up on it, and you can send me a message on the general group, And if I have some downtime, I can sync with you and guide you on creating it. All right. So any questions? All right. In the absence of questions, we've come to the end of today's class. I'm going to send a video that I want you to watch. Please watch it. It's the top AWS services that you need to know. So that's part 1. There's a part 2. I'll share that with you once you've watched part 1. But that's going to be half of your exam. So make sure that you really watch it, understand it. If you're cooking, let it play in the background. If you're whatever you're doing, just let it be something that you are listening to. All right. Thank you so much for your time. Hope we're learning a lot, and I'll see you on Thursday, right? Take care and have a beautiful weekend, everybody. Bye.